In this example, we will find the domain of the function given here as 2x cubed minus 1 divided by x squared plus 2x minus 15. So what type of function is this? So you can see here at the top we have a polynomial function, and at the bottom we have a polynomial function. So we know that if we have a cosine function where we have the polynomial at the top and the polynomial function at the bottom, that type of function is known as rational function. So how do we find the domain of the rational function then? So how do you find it? So what we just need to do is we just need to look into the polynomial that is on the denominator, and then we need to see where that is equal to 0, and then wherever, for whatever real number the denominator is equal to 0, we need to exclude that from the domain of the function, right? So if that is the case, what can we say? The domain of the this function is set of all real number where the denominator is not equal to 0. So to do that, let's first try to see where the denominator is 0. So we want to see first where x squared plus 2x minus 15 is equal to 0. And when we figure out those real number, if it exists, then we exclude that from the set of all real number. Okay, so let's try to do that. All right, so how can we solve this equation? How would we solve this? This is actually look like a quadratic equation, right? So how do you solve it? What we can do here is a couple of ways, right? We can either use the quadratic formula, or we can just see if we can factor up to the linear factor. So let me try with factoring up to the linear factor here. So I have x squared here at the first term, so probably having x and x as the first term of the linear factor would be sufficient, right? But on the other hand, now I have 2x here on the this linear term, and then at the constant I have negative 15. So what I need to do is I need to see two numbers whose product is, let's say, negative 15, and when I combine I need to get at positive 2. How is it that how is it possible? So here it's given negative 15, right? So how can you get two numbers whose product is negative 15, but when I combine I can get 2? Can you think of those two numbers? All right, yeah, okay, so we can choose positive 5 and probably negative 3, right? So when I multiply these two, 5 times negative 3 will be negative 15, but when I combine 5 minus 3 will be positive 2, right? So positive 5 and negative 3 are the two numbers. So let's have that over here, and then just get the linear factors of this quadratic expression we have over here. Now set that equal to 0, and then we can now just solve for x, right? So how can we solve this for x? Now you can use the zero factor property, so which will tell us this product that we have over here is equal to 0 if x plus 5 equal to 0, right? Or x minus 3 is equal to 0. And then we now have just two linear equation. We can just solve that. So for example, here on this equation over here, I can just subtract 5 on the both sides, so I can get x equal to minus 5 as a solution, right? And then I can here add 3 on the both side, and then when I solve for x, I get x equal to 3 as a solution. So what did we get here? We get here that at x equal to minus 5 and then x equal to 3, this equation over here is 0. So that means the denominator is 0 at that location. So if that is the case, if you draw a real line over here from minus infinity to positive infinity, which is actually the possible domain for the rational function, but it turns out that at these two locations, at negative 5 and negative 3, the denominator is 0. So if that is the case, the domain of this function is all real number except negative 5. So we need to exclude that, so we can have the parenthesis here on the left and right, so that we exclude negative 5, and all the real numbers between negative 5 and also 3, excluding 3, because at 3 the denominator is 0, so we can also have another parenthesis on the left and right, so and all the real numbers from 3 to infinity. Yeah, that's it. But if you want to write down the answer on the on the interval notation, this is how we can write down. So the domain The required domain of this problem will be negative infinity to negative 5, right? And then from negative 5 to 3, right? And from 3 to infinity. But we can combine all of these separate interval by the union sign. And then that concludes this example, this problem where we needed to solve how to find the domain of this given rational function.